Hey, what's going on, everybody? It's Tyler here, and today we're going to continue where we left off with our system information application and actually get this content, which is currently static and doesn't change. It's always going to be 25.4%, and actually get this to dynamically display the CPU usage of our application. So let's just get started with that. So the way we have to think about this is right now, we can't really get CPU information or any system information inside of our renderer process. And the way we're going to want to basically do this is we're going to want to have a preload script where we could pass in specific functions to our renderer process to be accessed in here, and then have a function, say, called get CPU usage. So how do we do that? Well, one thing we're going to want to do is in our web preferences object, which right now I just have DevTools shown as false, what we're going to want to do is have a preload script. And I'm going to just do the same thing we've been doing. I'm going to do path.join. I'm going to pass in the directory name. And then I'm going to do /backend, because I think it's about time we actually start separating our front-end code and our back-end code. So I'm going to do that right now. So I'm going to do /backend and then you can just do this, dir name plus /backend, and then we'll do /preload, preload.js. Now let's create that in our source directory. So we're going to do backend, and let's create our preload.js. Okay. Now, I'm also going to do a little bit more maintenance to our application right now. So one thing I'm going to do is we're going to have a backend folder for all of our backend code. And then we're going to have a front-end folder called app, let's just say. And in here, we'll have our index.html and our style.css and any other things like that we'll need in the future. Which means what we're going to need to do is update our path so that way it correctly displays this in the dir name. So we'll do /app/index.html. And other than that, I think everything else should be fine. So in the backend, in the preload script, I'm just going to console.log hello from preload. Okay. Clear that up and then do npm start. And as long as I didn't mess anything up, we should still see the normal application, but we should also see hello from preload. And that means that this script right now is getting ran before our actual HTML and all the other stuff is finished. And the reason we can test this is we can do this. So watch what happens if I put a script here and I say console.log this is the renderer process. And watch what happens here, okay? So we get hello from preload, and then we get this is the renderer process. We will never get this message before this one, and it's because, as the name suggests, the preload is preloading the contents. But what's different about this and that is in here, if I do console.log os.cpus, which for those of you who know Node.js, you know that that is how you get the CPU's information. But what you see here is OS is not defined. And we can do like let OS OS equal require OS, and maybe it'll change. No, and again, require is not defined. But if I was to then take this same exact code and put it in the preload script, you'll see it'll work. And the reason it'll work is because the preload script has access to Node.js, while the rest of the scripts after this preload script will not. This is very important because it means we can get Node.js specific information and pass it to our HTML, but not the other way around, which means we don't have to worry about having insecurities that you've probably seen in tutorials with Node integration. So one of the things I wanted to show is that this is why Node integration set to false works the way it does and why we need a preload script. Because we want to get this information inside of this file, but not the other way around. So enough ranting. Let me actually show you how we use this preload script. So first thing we're going to want to do is actually keep our OS is equal to require OS. That sounds about right. And then I'm going to do this const Ipc Renderer, Renderer, and context bridge is equal to require, and these are going to be coming from Electron. So Electron has two more objects / methods that we haven't talked about yet. One of them is Ipc Renderer, and one of them is context bridge. Context bridge is how we can actually create a sort of API you can think of. So we can do context bridge dot expose in main world. And this takes in an API key, which it says is a string, and I'm just going to call it app. And it takes in an API, which I'm just going to call API. And you may be like, okay, what is this? Well, if I create this API instead of equal just to a blank object, you'll see that then what I could do is I can create a little script tag again, and I can console.log app. And you may be like, okay, I'm lost. What's this app? Well, app is what we defined here. Basically, the way this is working is the preload script is taking this script and it's saying, okay, context bridge.expose in main world. What this is doing is it's now creating a new object called app. So it's going to do window dot, and it's creating this new app object, which before does not exist. And it's setting it equal to whatever's inside this API bracket. And this is really, really useful because it allows us to put things in here that have node related code in here and access them inside of our HTML. So let me just, let's just go into the console and see what we get. So remember, I console.logged, I'm just gonna quickly expand this. Okay, there we go. So I console.logged app. So I can do window.app. And what you see is if I hit enter, we just get an empty bracket, which is not very exciting. What if I want to get the CPU count? So I could do CPU info. Okay, and watch what I could do. I could do os.cpus, boom. And the second I hit save, we're going to get a new thing inside of here. So remember, we're console.logging app. And I'll just do this so you can kind of see where it's coming from. Window.app is where this is really at. So we have this CPU info object. And what you can see is this is all of the stuff about our actual CPU. My CPU on my machine. But I can access it inside of the renderer process, which is something you normally can't do with JavaScript. For example, but you can see that I don't have access to OS as a whole. Like I can't do os.platform. This will throw an error because OS is not defined in this area. Window.app.os.platform won't work either. None of this will work. The reason is we're preloading only content inside of these brackets. So I'm saying, hey, I want to put an object or a property called CPU info, and I want it to be equal to this. Now, what if I want to have it be equal to a function? For example, I could do something like this. I can create a function called, say, get version, I don't know, and do something like this. And what get, say, hello, I don't know. And what I can do, or get platform, we'll just call it that, platform, okay? And what I could do is then just return os.platform. Now, watch what this does. I can create a function in here and do get platform, set it equal to a function. And I'm going to do an arrow function, and I'm just going to call the platform function right here. So what this is going to do is if I console.log it again, what you'll see is there is the CPU info object, and there's this function, as you can see by the F, get platform. So I could do app.get platform, and watch what we get, win32. So you can kind of see how really useful this will be. We can get CPU information as well as anything else we want. I mean, right now I'm literally just getting the OS. We can get anything in here. So let me actually show you how we can do this usefully. So I'm going to get rid of these two right here. And I'm going to want a way of getting the CPU usage. I'm going to call it get CPU usage. Or I'm just going to call it CPU. CPU usage. And this is going to be a function that does something with our Ipc renderer. So I'm going to do Ipc renderer.invoke get CPU /get. That's how I like doing it. There we go. Okay, so if you haven't used Electron before, which I'm assuming you haven't, Ipc renderer is a way for us to communicate between processes. So the renderer process is where we technically are right now. Remember, we're loading this into our HTML. Ipc renderer lets us send messages directly to the main process. So you may be like, okay, what does that mean? Well, when I call Ipc renderer.voke, it's sending a message to CPU-get. And we can listen for that message inside of our index.js. And this is our index.js file. We've been using this before. And I can do something like this. Up here, add Ipc main. And this is our main process. It's Ipc main for the main process. Ipc renderer is for the renderer processes. And we can do Ipc main.handle. Okay. And handle takes in a string and then a callback. And this string is just what we passed in here. CPU/get. So we could do CPU/get. So we're going to listen for a message with this kind of tag you can think. And we're going to then do something with it. So we have access to the event and the handler, or that, and the data that's passed in, because we can pass in data. So if I pass in hello from the renderer here, we can get access to that with this data. So I'll just console.log data. And then what we can do is this handle, as it says, adds a handler for Ipc renderer.invoke. And what it does is it passes back a promise. So this is an asynchronous operation. So say we want to get the something that takes time. Like say we want to get the CPU usage and we want to get it, but we don't know how long it's going to take. So it might not be instant, and it actually won't be. One of the things we can do is we can then do something like this. Return, here would be some data. Okay, so what's going to happen when we restart this application is we're going to have a new event listener. And watch what happens here, okay? I can do this. So we have our object, we have CPU usage. Watch what happens if I do console.log app. Actually, I can zoom in here as well. Sorry about that. So app.get or CPU CPU's usage. Okay, and watch what happens here. We get a promise. And the reason we get a promise is because this is not, this is an asynchronous result. And here you can see we console.log the data, and it says it right here, hello from the renderer, because this is what we passed in as data. And in fact, we could do something like this, where we pass in data via here. So data, and we can do this, where now we can directly pass in data from the renderer process. And here you can see I'm returning. Here would be some data. So watch what happens if we go back, and instead of just console.logging it and it telling us we have a promise, we can do app.get or CPU's usage then. So we'll have access to this data. I'm just going to console.log the data. And there we go. And here it is. So we get the promise, and then it says here would be some data. And it's because in the main process, we sent back here would be some data. If this was something else like actual CPU usage information, we would get that in our render process. Now, currently, we're using the terminal, which is kind of annoying, and it's not really that useful. I was just using it for demonstration purposes. Let's actually create a renderer.js file. So we'll call it renderer.js. And in this file, we now can access our API and do whatever we need to do with it. We just need to include it down here. So I'm just going to do script source and /, Renderer.js. I'm also going to add a defer attribute so it loads in later. And we'll add a type of module because I do like using the module system. Okay, so in here, we can kind of do the same thing. We can create an asynchronous function called get CPU usage. And in here, what we can do is we can do const usage is equal to await app.get CPU use. What is it called again? I already forgot. We'll just call it CPU usage like this. So it looks a lot better. Okay. So we can do app.CPU usage. And in here, we can also pass in our parameter. I'm just not going to do that for now. And then we can console.log our usage. And again, currently, this won't actually return anything useful. If you see, when we restart the application, we can now do like set interval for every 1 second and just run get CPU usage. And what you'll see is that nothing exciting really happens here. 5, 6, blah, blah, blah. You can see we're getting undefined in the terminal, and that's because we're not passing anything in. If I was to pass in the date.now, for example, what you would see is we get dates now, which is still not very useful. So again, I'm not going to really pass anything in. And in here, I'm just going to get rid of this console.log. But you can see that we are getting back some sort of data. So let's now actually get the CPU usage. And what we're going to use is a library called system information. And it's called systeminformation.io. So we're going to go to systeminformation.io. And what you can see is they have a whole bunch of different system information you can pull from. We're going to go to CPU. And you can see how they expect us to use their API. We're going to basically want to install a package called system information, and then we'll get all of this information. Yeah, so let's do that. First thing we're going to want to do is clear the console and close the process. And we're going to do npm install system information. Okay, and now that we have that installed, what we're going to want to do is go into the index.js file, and I'm just going to do const si is equal to require system information. Perfect. And what we're actually going to do is we're just going to pull in some of these functions, like CPU current speed. We can pull in current load, CPU we could pull in, all these things we might use in the future. So might as well pull them in. What we're going to do then is we are going to do const usage is equal to await current load. And this returns a promise, which means now we can just return the usage. And now that we have this all figured out, what we can do is finally restart our application. Oh, sorry about that. 1 second. There we go. So we can actually restart our application. And what you'll see is when we actually console.log what we're getting back, you can see we're getting all of this data back. We're getting the CPUs, so we're getting the load per individual core. We're getting the system, all this stuff, and all we had to do, and we're getting it every second as well, which is really useful. So what we're going to do now is actually display this data on our application. So to do that, I'm going to close that and close the preload script since we don't really need this anymore. And what we're going to do is, instead of every 1 second, we're going to do it every 2 seconds, just because I think that's nicer. And what we're going to do is we're going to do const overall used. I'm going to call it used overall is equal to usage dot, and I don't remember it off the top of my head, so let me look in here. Usage dot current load. Okay, and what this returns, if you look, is a percentage of the current CPU usage. You can see we're using about 8.27% at this exact polling request. So what we're going to want to do is now update the progress bars, and the way we can do that and the text as well. And the way we can do that is inside this renderer file. So up here, I'm going to create these HTML elements. I'm going to do const CPU used text is equal to documents dot get elements by ID, pass in the CPU used, and then I'm going to do the same thing, const inner bar CPU is equal to documents dot get elements by ID inner dash bar. Perfect. Okay, so now that we have that, what we can do is we can create a function called update percentage. Perfect. And what we're going to do is just create that function real quick. So we're going to create a function called update percentage. It's going to take in a percent. I'll just set it by default to some minuscule percentage. And then what we're going to do is we're going to set this inner bar's percentage to this percentage. And the way we can do that is, let's set it to 0 by default. What we can do is we can do inner bar.style.width is equal to, and we'll do a template string of percentage.toFixed we'll just do 3 decimal places px, oh no, percent. Perfect. And we don't actually really need more than one. Okay, so this is actually all we'll need to do. So we can pass in this update percentage and we'll just do used overall. There we go. And what you'll see is now the percentage is updating every 2 seconds based on our actual CPU usage. So what I can do is I can also console.log percentage and see how accurate this is. What you'll see is, there we go, 9%, 9%. That looks pretty much like a 9% CPU usage. 4%, 7%. Yeah, that looks pretty good. So now let's actually fix and get this text to update as well. So the text, again, is really simple. All we're doing is displaying the percentage. So we can kind of do the same thing here. We can set it like this. And I'll actually just create a new variable like called pertext, const pertext is equal to this. And then I'll just set the CPU use text dot inner text pertext pertext, and what you'll see is it will now update the application CPU usage in real time. So I think this looks pretty good. In the next episode, I'll finally add some styling for possibly a light mode, dark mode, and in future episodes we'll not only do CPU usage, we'll also do memory, network, and we'll add more graphs so that way we could show other information like the idle usage between users, and usage by programs. So I hope you found this video useful. It was a bit of a long one, but if you liked it, please like, comment, subscribe, and I'll see you guys in the next one.